Welcome, dear students, parents, and all of the Colegio del Pilar. We're really happy to be here with you. This is just a small reminder that we are about to start in 5 minutes sharp. So, thank you, every single one of you who is already connected and waiting for the conference. And I'll see you in a couple of minutes, okay? Thank you. Good afternoon, Colegio del Pilar, the whole Colegio del Pilar community. We are really, really happy to have you here. Thank you so much for every single one of you who is waiting now. Hello, everyone. And we start in a couple of minutes, okay? So thank you so much. And we start in 4 minutes. Thank you, kids. So good afternoon, every single one of you. I am really happy to be here with you. We're about to start the conference, so thank you so much for joining. Thank you so much for waiting for the conference, and let's start. Right, welcome every single one of you. Um, so, um, Distinguished guests, directors, teachers, and students, my name is Marco Rios, and it is my great honor to be your host moderator to Julieta Fierro's conference, The Light of the Stars. I am extremely glad to welcome you to the opening of the Colegio El Pilar Virtual Science Fair, and to do so, here with me is Dr. Julieta Norma Fierro Gossman. Um, Dr. Julieta Fierro is a full-time researcher at the Astronomy Institute of the UNAM and a professor at the Faculty of Sciences. She occupies the 25th chair of the Mexican Academy of Language, and it is an active member of the National System of Researchers. Julieta Fierro's area of work has been interstellar matter, and her most recent works have been related to the solar system. She has been a professor at the Faculty of Sciences of the UNAM, and she has recorded a free access online course as well. Julieta Fierro's most outstanding work is in the dissemination of science. She has written 45 current books and dozens of various publications. She also participates in radio and television programs. Furthermore, she has given hundreds of conferences in 39 countries around the world. Throughout 52 years of activity, Julieta Fierro has received distinctions such as the World Academy of Science Dissemination Awards, the UNESCO Kalinga Prize, and the Klumpke Roberts and the Primorovy Gold Medals from the Tristy Center for Theoretical Astrophysics and the Citizen Merit. She has 3 honorary doctorate degrees and also several laboratories, libraries, planetariums, astronomical societies, and 5 schools bear her name, Julieta Fierro. So, Dr. Julieta Fierro, thank you so much for accepting the invitation and welcome to Colegio El Pilar. Parents, students, remember you can use the comments and the chats on the YouTube channel. Thank you once more to be here with us, and the floor is yours. Thank you so much, Julieta.
Thank you. Thank you. Good afternoon. Well, I'm going to try sharing the screen. I hope I'm able to do it. Okay.
Actually, we can already see the projection. So you just you can let me know when I put next, and that's it.
Can
or
you
want to
now?
Excuse me?
Can you see my projection now? The one I'm sharing?
The one you're sharing, not, but I have the projection here already projected. The presentation already projected.
Okay, so you're gonna do the projection. Okay. Well, thank you very much. I'll just make a sign so we don't say the next, which is quite annoying. Okay, I'm Julieta Fierro. I'm delighted to be here. As you know, I work at the Institute for Astronomy in Mexico's National University. And I have an email address that you can access whenever you like. It's quite easy. It's Julieta, etc. And I have a homepage where there are lots of stuff. There are books for small kids and for medium students, and there are videos, etc. Thank you. Please, the next. I'm very grateful to the school. Thank you for the invitation. It's very nice to be with all your students and parents and other teachers. Well, as you know, I'm going to speak about astronomy. If you have any questions, you can always email them to me, and if I know the answers, I'll be delighted to write to you. We usually look at next, please. We usually look at the stars naked eye, and we see only 2,000 stars during the night. Very few stars. But astronomers have to do something about this, because actually we don't enjoy just looking at a few amounts of stars. We'd like to see even more. So, and what is the reason for this? Next slide, please. In order to see colors of objects, we need lots of light. That's why painters speak so much about the right illumination of a certain object they want to draw. But when there's a low intensity of light, colors aren't as bright. So we need lots of light in order to see colors. All the light that comes into our eyes gets through the retina, that is actually very, very small. If you see my retina, it's minute. It's the black part of my eye. So in order to see things with less amount of light, what we do is enhance the diameter of our retina. And what do astronomers do in order to do the same thing, but much at a further extent? Well, in order to have large retinas, what the astronomers do is they use some sort of funnels for light that are called telescopes, and this way they can gather larger amount of light. They actually don't use telescopes, they use other instruments, for instance, magnifying glasses or mirrors, in order to funnel the light towards cameras or other light detectors. Many of the telescopes are now orbiting the Earth, where there's no atmosphere, or where there's very scarce atmosphere. And this is very important, because atmosphere has clouds, it can have dust, and it is turbulent. That means it moves from one place to another. And this makes stars twinkle a lot, and they change their positions. So, and simply if it rains, you can't use a telescope. So it's very important to have airborne telescopes. And this way we can actually see the colors of the stars with telescopes. And this is very important for astronomers, because in the first place, it shows us that not all stars are the same color. And although we don't know the distance of the stars by just looking at them, we can know their temperature. The bluest stars are very hot. The orange ones, like the sun, are medium temperature stars. And the red ones are the cooler stars. The cooler stars are 2,000 degrees Celsius. The ones like the sun are 6,000 degrees. And the blue stars are about 40,000 degrees. So how do we know the distance to the stars? How do we know all those stars aren't just at the same distance? Well, we use a technique that is very simple. If you look at your finger with one eye and then with the next, I suggest all of you do this. So place your finger near your face and look at your finger with one eye and then with the other. And you will see that your finger seems to jump from one place to another. Now put your finger the furthest away you can. We're really far away. And you will see that now the finger moves less. So if it's near, it jumps a lot. If it's far away, it jumps much less. So the further away a star is, the less it jumps. Of course, we don't use fingers nor eyes, but we use the position of the sun, the position of the Earth at different places of its orbit. So we can see a star that's nearby with one position of the Earth and another, and then when I'm sorry about this, and then when the star is far away, it seems to jump less if we compare it with further away stars. So this is the way astronomers find the distance to stars, the same technique as we could figure out the distance to our finger watching it from our different eyes. And so this has allowed us not only to find new stars, but also new planets. How do we find new planets? Well, the first thing astronomers did was to find nebula, where stars are born. This happened because when the first space telescope, the Hubble telescope, was placed in orbit, it was out of focus. It needed glasses like I do, because I can't see faraway objects, just near ones. So this telescope was built in order to watch galaxies that are very far away, but instead it had to be used to observe nearby objects such as this nebula. And they discovered that inside the nebula were these strange shaped objects that turned out to be stars. Next, please. Stars that are being formed, stars that are being born. When there's a cloud in the interstellar medium and it cools down, most of the mass goes to the center of the cloud and it starts to heat and turns into a star. And with the matter that surrounds the star, planets are formed. These disks are formed because the matter around the star is spinning. Usually all celestial objects are spheres. The Earth is a sphere, the sun is a sphere, the moon is a sphere, because gravity pulls everything towards its center. But when an object is spinning, for instance, if I spin this bag, well, it would be flattened, like the skirt of a ballerina when she's spinning. So the planets form around the stars in a plane. In recent years, more than 4,000 planets that spin around other stars have been discovered. One of these stars, for instance, is named after Cervantes, one of the great Spanish writers, and it has 4 planets. One is called Dulcinea, another Rocinante, another Quixote, and another Sancho. And it turns out that Quixote has water and an atmosphere like our Earth, and Sancho has rings around it. So how can we find these planets? We can't actually see them with our telescopes. We have to figure out their existence. So let's say I have this board. It's just a cardboard board. And I'm going to place this object on top of it. It's not glued to it. If I let it go, it falls. And I'm going to go kind of far away so you can't see it. And if I make it spin, well, the object doesn't fall. It stays stuck to the board because it's spinning. Well, the moon doesn't fall towards the Earth because it's spinning around the Earth. and all the planets don't fall on the sun because they're spinning, and other stars can spin one around another, or a planet can spin around its star, and they remained together. So how can we discover these exoplanets or planets that spin around other stars? Well, let's suppose we have two stellar objects, two stars or two planets that are the same size. And let's pretend this stick is the gravity that's holding them together. And let's see how one would spin around the other. So I have a string here, and I'm going to place it. I'm sorry, but the camera turns left to right, so that's why I'm so clumsy. Well, if one makes them spin around each other, we see they turn around the middle. So if we have two planets or two stars that are the same size, they would spin around the center of mass. That's the name of this point that's in between both. Now let's suppose instead of having two objects that are the same size, one is larger than the other. What would happen? Well, now I'm going to use a bigger Play-Doh ball. And if I place it on the stick, now the center of mass comes closest to the heaviest mass. And we can see how objects turn around the new center of mass. Now let's suppose one of these objects, let's say the blue ball is a star and the orange ball is a planet. Let's pretend it has a ring. What would happen? Well, when one spins around the other, it will cover it. So the light from the blue star would disappear and then appear again. We'd see both objects and then one and then only the other. And this is the way we discover planets that are far from the Earth. Next, please. So if we see a star that moves in a straight line, it has no companions. But if we see a star that has a wiggly trajectory, that means it's pulled from one place to another, then from one place to another, and that would let us know that it has a companion. Next, please. And we have space telescopes that have been specially designed to discover extrasolar planets. For instance, Kepler telescope, but there are several others. And when a planet goes across its star, it absorbs part of the light, and that makes us know there's a planet there. Next, please. And if it has an atmosphere, well, the atmosphere would absorb part of the starlight, or if a planet with rings around it would turn across its star, we could discover its rings. And we have found Saturns that are 200 times larger than our Saturn. If our star Saturn would measure 1 centimeter, well, this Saturn would measure 2 meters. So they're really big. Mexico has an observatory at San Pedro Martir. It's one of Mexican observatories. It's in Baja California, and it's in a great place because, please, what before? Thank you. It's a very dark place. Even during the night, there are no lights that make it difficult to observe stars. When one is at the peak of the observatory, it's It's so high that one can look at the Cortes Sea or at the Pacific Ocean at the same time. And all the villages and cities that surround the observatory can't have lights that shine on the sky. They have to have some sort of umbrellas, so all the lights shine towards the streets where people walk, where they're useful. And at this observatory, we have a telescope that's named after a French writer, Saint-Exupéry, that wrote the Little Prince book, and we have a robotic telescope there that is wonderful because astronomers don't have to travel there. Most of the telescopes now are robots. Astronomers don't have to travel so much anymore, and besides the space telescopes, don't need an astronomer up there. So we can now discover planets from Mexico, and we have actually. What would we even the closest star, Proxima Centauri, that has two planets that spin around it. One has water, by the way. Next, please. There are all sorts of different planets. For instance, some are lava planets. They're completely molten. Other planets have such a high density that inside them there are diamonds. And as I mentioned before, 4,000 exoplanets have been discovered. Lots of them have water. And as you can imagine, scientists would love to discover different kinds of life in the universe. And we know, at least on Earth, if there is water, there is life. So we'd love to discover, inhabitants in other worlds. Astronomers also like to watch nebula. These are places where stars are born, as I mentioned before. And we don't only use ordinary light to study objects. We also use, for instance, radio waves or infrared radiation. If you I can't find the word. If you rub your hands one against the other really, really fast, do it really, really hard, you'll see that they become very hot. And if you place them next to your face, you'll see you can feel the heat from the radiation. So rub them really hard and then place them next to your face. You'll see that you can feel this radiation. Well, stars and interstellar medium also produce this kind of radiation. For instance, the Horsehead Nebula. Next picture shows us the nebula seen in visible light. As you can see, it's dark. But in the previous picture, if we see it, it's bright red, because this is an infrared image of the same object. Next, please. So as you can see, astronomers use all kinds of radiation to figure out all about the objects in the universe. We also, watching lots of different kinds of of objects, we can find out the way they change. The same way you can observe lots of different people and babies and elder people, you can sort of imagine how your lives will be. You know, you were born and you were a baby for a few years, and then you're children now, and eventually you'll become adults. The same happens with stars. Stars spend most of their life as adult stars. Oh, excuse me, I have a phone. Let me hang up. outbound. Estoy en una conferencia. Estoy en una conferencia. Okay, so all stars are spheres. So here I have a balloon. And as I mentioned before, celestial objects are spheres because gravity pulls everything towards its center. That's why the stars are spheres, the planets are spheres, many satellites are spheres. But what's amazing is that even the sun and the stars that are made out of gas are spherical. And the reason is the following. Gravity pulls the outer layers of the stars toward their center. But the pressure of the stars pushes them the other way around. So if I place the balloon on top of the dryer, well, it pushes upwards. And if I increase the pressure, it goes up. And if I turn it off, it falls. So the same kind of things happen with stars. When the pressure increases, they become larger, and when the pressure decreases, they become small. And when their fuel burns out, they simply collapse. So 4,500 million years from now, the sun is going to grow so much that it will become a planetary nebula, an object like this one. The previous one, please. The sun will grow, it will become a planetary nebula, an object like this one, and the center of the sun will be very hot, it will turn out, and this atmosphere will expand. The Earth will melt and it will move in space and most likely mix with another interstellar gas cloud and form a new planetary system. But the largest stars of all explode, please, at the end of their existence. Why do they explode? Well, let's say this is the central part of a star, and this is the outer part of a star. When the star turns off, the outer part flies out. Let's do it again. So you see, the outer part flies out. So the largest stars of all explode when they finish burning their matter. Stars form galaxies that have 1 billion stars. And galaxies are made out of stars of different colors. And as I mentioned before, looking at the colors of the stars, we can know what they're made out of. Next, astronomers don't only take images of stars, they always also take their spectra. For instance, when the sunlight shines on my ball of detergent in the kitchen, I can spread out the light in different colors like a rainbow. The same happens if I use a disc. You see, you can see the rainbow of the sun that's coming from my window, or even if I use a plastic bag, you can see the rainbows of the different colors. So the astronomers, next please, compare the rainbows of substances we know on Earth and we compare them to substances we see in the universe. And this way we can know what stars are made out of. Next, please. Next. We also use filters in order to enhance the pictures we see. So many of the pictures that we see in books, they are so beautiful, they're actually made with different filters. For instance, if I place a red filter in front of the camera, with the colors you see are different if I place a blue filter in front of the camera. So many of these beautiful images that we see in books are made this way using different filters. If you put a drop of water on your television screen, you'll see that all colors are only built out of red, green, and blue. And mixing these light colors, we can reconstruct any kind of images. Please, the next. And galaxies are the largest objects in the universe. There are clusters of galaxies. There are thousands of galaxies in every cluster, and every galaxy has billions of stars. Now, these galaxies don't remain in the same place. We live in a universe that's expanding. I have this ball here, and if each point of this ball would be a galaxy, well, all of them recede one from the other. Every time the galaxies move faster and the universe expands at a faster pace. So if we measure the expansion rate of the universe, we can know when it was all together, and that way we can know the age of the universe. And it turns out that the universe has an age of 13,800 million years. Now, if our universe were static, if it wasn't expanding, it would collapse. So if the universe would stop expanding, it would collapse because gravity would make it collapse. So it's necessary for our universe to be expanding in order for it to exist. Next, please. And it's very interesting because the way we know the history of the universe is not only by seeing the way it expands, but by observing objects that are further and further away. When an object, all the stars and the galaxies emit light, but this light takes a certain time to reach the Earth. For instance, the light from the sun takes 8 minutes to reach the Earth. The light from Pluto takes 4 hours. The light from the nearest star takes 4 years, etc. And there are galaxies that are so far away that their light takes billions of years to reach the Earth. So when we look farther and further into the universe, we see objects as they were, not as they are at present. Astronomers don't only use light to study the universe. They also study meteorites, chunks of matter that fall from the sky. Mexico has many fine specimens because we have these enormous deserts in Mexico, and when a meteorite falls, it's easy to see it on top of the sand because the jungles don't cover it up. We also have telescopes that are, for instance, at peaks of mountains. On the, I don't know if you have the right or left image, but in my image, on the top of the Sierra de la Negra, that's the volcano that's on the left, is this telescope. The next telescope is right next to the Pico de Orizaba, and this is a radio telescope that uses radio waves to observe the stellar objects. But you know something? Nature just gave astronomers a great gift. When we watch a dog, for instance, we can see it, we can listen to it, we can feel it, we can smell it. Every one of our senses gives us different information. So next, with a different kind of lights, with radio waves, or I'm sorry, it's in Spanish, or optical waves or infrared, we see different aspects of different stellar objects. But now we have a different way of studying objects, and these are the gravitational waves. If you toss a stone in a pond, well, waves would move across the pond. And what Einstein suggested was that space would also produce waves if something happened to gravity. For instance, if two black holes would collide one against another, well, these waves would travel through space and would jiggle, make the Earth jiggle. And this has actually been measured. Next picture. When a gravitational wave is produced by colliding black holes, the Earth wiggles very little, 3 centimeters. But if we place mirrors in different laboratories, well, we could see how different mirrors move, and this would be a detection of these collisions. Astronomers use their brains, which is a magnificent instrument. Each of you has a brain that's completely different. If I toss a ball, well, all of us could more or less imagine how it would move. But if I inflate a balloon and I let go, it would be very difficult to predict its trajectory. This is chaos. This is the name of the physics of this century. It explains many things. For instance, why each of your brains is different from one another. Each of you has the possibility of using your brains in a different way, of creating things and imagining things and solving problems in different ways. And that's why it's so important to go to school and study and train your brain to think, because you might have a more interesting life. Thank you very much.
So thank you so much, Julieta, for this conference. I think, and I have seen it in the comments that they have shared with us, the whole community of Colegio El Pilar, not only on our students mainly, but also parents, that you turn like this learning of science and space fun. I was with a smile in my face the whole conference. So we want to really, really thank you for it. Parents, students, you might leave some questions for Julieta if you want to share something with her, like a big concern, and we can probably take just a few minutes to explain them. I was reading to a question which I actually thought it's pretty interesting when you were talking about the clouds that form around some planets. And one of our students mentioned if those clouds are they formed or are they based on the same material as the clouds that we can find here on Earth?
The clouds in our atmosphere are mostly water. These interstellar clouds are formed by a mixture of chemical elements. Their composition is similar to the gases from the sun. And these clouds form stars with all the chemical ingredients that our sun has more or less, and the planets as well. The planets that are near the star are stones because the sun was so hot when the planets were formed that the sun evaporated most of the gases they contained. Whereas planets like Jupiter and Saturn are gaseous planets because they're more similar to the sun, because the sun didn't evaporate these substances. Water on Earth came afterwards. Our Earth was practically a stone, but then comets fell on Earth, and comets are mainly made out of water. This is how our Earth came to have these oceans.
Thank you so much for sharing. Well, we've received a ton of messages telling that you are a true inspiration to keep on studying sciences, and they are really happy for the conference. And well, once again, I would like to thank you for being here and for accepting the invitation. And thank you once more. The whole community of Colegio El Pilar wants to thank you too. And I think Miss Cynthia would like to share just a message with us. And that would be it. Thank you, Julieta.
Thank you. Remember, if any of you have questions, you can always write to me. Julieta@astro.unam.mx, Julieta@astro.unam.mx, and I can forward you my homepage. So there's a book for small kids on it. So if you have many questions, I will forward you to my book. Otherwise, I will answer them, even if they're
Thank you so much.
Well, thank you so much, Dr. Julieta. It is a great pleasure to be with you. And I was reading the chats, and some of the students, they said that it's inspiring. So thank you very much for being here. And I just want to say welcome to all of you to our first virtual science fair. And it is a great pleasure to invite you, all of you parents, Julieta, and everybody, directors, to have a journey for our natural world. Our goal is to answer questions based on hypotheses. Students, they have been working with different science projects. They have been conducting different experiments. And I just want to share with you some words. Every brilliant experiment, like every great work of art, starts with an act of imagination. And I think every time we need to share with the students, with kids, even though we are kids, if we are adults, we need to keep that creation, that imagination. So thank you very much for being here. It's a great pleasure. And obviously, we are going to write different questions because I know that we have many and we want to keep contact with you. Thank you, kids. Thank you, parents, for being here. And now let's going to enjoy our presentation.
Thank you, and I hope you recover your freedom.
Wow, that's great. Congratulations. Thank you very much. Thank you. So, parents, thank you.